Okay, so welcome. This is a Edexcel C4 June 2008 past paper. This is question 2, which just requires you to do a bit of obviously integration. Now this is specifically integration by parts. It's quite a nice overall because it's only one method for both parts of this question. Okay, so the first part just asks us to integrate this. Now the first thing I do with these questions, whenever we're asked to integrate something and there's a rule behind it, I'll write out the rule, okay? And the rule is the integral of u dv dx is equal to uv take the integral of v du dx, okay? So we correspond this with what we're currently given, okay? So therefore u must be x, okay, and dv dx must be e to the x. Now, the reason why I can say that is because it's in the order. Basically, u is always the first term unless we've got an ln in there, or a log, okay? Hopefully that makes sense, right? Anyway, so just apply the other. What we want to find out now is du dx, which we don't have, which is obviously just 1, okay? And we want to work out v, which is the integral of e to the x, which you should know is e to the x, okay? So the integral of x e to the x dx, okay, we compare it to the one above, so it's equal to uv, which is x bracket x times e to the x, okay, take the integral of v, which we know is e to the x, times du dx, which we know is 1, okay, so it's simply just x e to the x, take the integral of e to the x, which is just e to the x, okay, so it's simply x e to the x, take e to the x. Now you can't take them away and just say, oh well, that's x, because remember this is x times e to the x, and that is simply just e to the x, okay? So that's part A. It's quite a nice part A. Nothing too strenuous about that at all, I should have thought. And it's just really quite a typical C4 kind of question, okay? So quite a nice and easy one. So moving on to part B. Part B asks us, well, it actually says, hence find the integral of x squared e to the x. Okay, now it doesn't look like we can use this answer straight away, so but we've still got an x squared and an e to the x, and we've got an x e to the x here. What it means is use the same principle. Okay, so we've got two products here and we're integrating two products, so they follow the exact same method that we did before, okay? So, as I said, you don't need to write this out, formula out again, because we've already wrote it out. But what we do need to write out is what u dv dx, v, and u du dx and v dv dx is, okay? Comparing it to this formula up here. U we said was x squared because we've not got an ln, so therefore du dx, instead of it being just x, it's just 1, sorry, it's a 2x, which is going to make things a bit more complicated when we get to the second half of the integration. Okay, dv dx, well that is still just e to the x, and v, well that is e to the x as well. Okay, now we apply this idea to this formula. Okay, so the integral of x squared e to the x, okay, we say that is equal to u, which is x squared, times v, which we said is e to the x, okay, take the integral of v, which we know is e to the x, brackets du dx, which is 2x, okay? Alright, so just let's carry on this as normal so far. So x squared e to the x, take the integral of 2x e to the x. Now that is quite difficult because, well, we can't just simply integrate that, because just like this is a product, this is also a product. So we're going to need to do another lot of integration, just like we did here. So basically we're doing integration by parts twice over, if that makes more sense. So we're doing it twice. Okay, so what we're going to do is integrate this bit and then shuffle every answer we get for the integral of this bit into here. Okay, now we can't use, don't be put off by the fact it said hence use your answer. You should have thought we should have got that, but that wouldn't have made any sense at all. Okay, I think what it means is just use the method essentially. Okay, so what I'm saying is just integrate this as normal. As you did this integral, we're just going to do this integral. But obviously it's going to be coming out to something a lot nicer. Okay, so what I would do is write u, v, dx, du, dx all over again. So u, we know, is 2x from this one. Du dx, therefore, is just 2. Okay? V is equal to... dv dx is equal to e to the x, so therefore v is also equal to e to the x, okay? So just follow the same principle. I'm not going to write this out again, okay? So it's just equal to uv, which is 2x e to the x, okay? 2x brackets e to the x. Take the integral of v, which we know is e to the x, times du dx, which is 2, okay? So it's 2x, take the integral of 2e to the x, and the integral of 2e to the x is just simply 2e to the x, because it's not 2x e to the x, it's just 2e to the x, okay? So we just leave that as what it was before, okay? So 2x take 2e to the x, and this is the answer to this integral here, so we just sub it back in, but a good thing to do would be to put brackets around it, okay? So x squared e to the x, take, and then we just sub this in brackets, because we'll end up with a double negative here. Okay, so take 2x to e to the x. Okay, and what we do there is simply expand this bracket in terms of taking it away. So that's x squared e to the x. Take 2x, take away negative 2e to the x, which we add to e to the x. Okay, now we can't add it to the first term because that's an x squared e to the x. So that's as simple as we can make it. But there's one thing that I purposely left out, see if you were paying attention, and that because I'm a pathetic maths teacher here, so I've missed off the plus c, so hopefully you spotted that, okay? So the plus c on both of these. Okay, and that is your end answer. Now, it does say in the marks here, it does go on to another step of taking out x as a common factor of that. So hopefully you can see that would just be x brackets x e to the x, take 2x, actually no, I'm not going to bother with that, because you don't get any extra marks for that, so you can just leave it as that. As I said, the mark scheme does show you how to take out the value of x, so please do check that out if you're not sure, but really you can leave it as that. I don't know why it said hence, because there's, apart from it's the same method, there's no extra information that we could have just worked out from that. I suppose maybe you could have done something about, I don't know, skipping halfway through, you know, because this is x squared e to the x and that's x e to the x, maybe you could have done something applying, you know, just skipping straight to one of these stages, but really you're more likely to get something wrong by doing that, as far as I can see. So, you know, if you do see a method that I've missed in terms of, because it says hence, you know, you generally use this answer for something. I mean, the only thing I can see here is we've got, well, this is 2e to the x. You know, you won't be able to spot the answers. There's nothing you can multiply this by to get this, because if you multiplied it all by x, you wouldn't get that. Okay? So as far as I can see, there's no direct pattern between these two, A and B, apart from the method. So I don't know why it says hence. But if you do have an idea, please do let me know. For the benefit of me and everyone else. But really, as I said, if you just follow that, you get the right answer anyway, so I don't see why you need to confuse it. Okay, so that's question 2 over and done with. Thanks for watching, and we'll see you in the next video.